In this video, I'll be going over the second part of enzyme inhibitors, whereby I'll be discussing lipopolysaccharides and acetaldehydes. If you have not watched the first part, do click up here. Watch the first part, then come back to this video for an overall summary. So what is lipopolysaccharides? LPS in short. It's actually a major component of the outer membrane of gram-negative bacteria. LPS is known as a potent toxin, and there's actually no safe level, meaning that even small amount can still pose a danger. I will go over the protocol on how you can actually remove all these enzyme inhibitors at the end of the video. So if you want to have the best information, please stay with me. In general, LPS will stimulate your immune response, which then activate toll-like receptors to release inflammatory cytokines. These are your TNF-alpha and interleukin-6, together with other inflammation mediators. Although these cytokines are crucial for bacterial infections, we certainly do not want them to be in excess or prolonged activations. An example of cytokine activations will be high fever, because LPS is a pyrogen, which can then stimulate hypothalamus to raise the body's temperature set point. Over here on the right here, there's a list of gram-negative bacteria, which can greatly increase the level of LPS in your body. And I usually use a GI MAPS2 test to keep a lookout of all these gram-negative bacteria. Notice I've highlighted H. pylori bacteria because this will be discussed in my upcoming video. Basically, H. pylori can release ureas, which can alter the environment of your gut and cause a series of gut-related issues. And if you Google online on LPS, a lot of disease like non-alcoholic fatty liver disease, gut inflammations, gut dysbiosis, irritable bowel disease, and leaky gut are highly associated with LPS. One of the reasons that these diseases are all linked with LPS is because LPS is a very potent inhibitor that will slow down enzymes like MAT and can potentially speed up the release of histamine. In addition, if you are someone who is exposed to mold, LPS will thrive in a mold-contaminated terrain. Together, they can actually proliferate and cause systemic inflammations and even promote biofilm formation. Then when that happens, a different protocol to eradicate those stubborn biofilm has to be done. LPS can also be influenced by how much stomach acids you have and the acidity level. And one of the reasons when you have decreased stomach acids is because of H. pylori. H. pylori and together with other bacteria can release ureas. They can alter the stomach's environment. When you have low stomach acids, you have a higher chance of getting secondary infections because right now your stomach is not able to fend off all these bed bugs. Then you will proceed on to gut dysbiosis. Another factor will be frequent antibiotic use, whereby you visit your primary care provider due to small infections. And you are being prescribed with all these antibiotic use. When you kill all the good guys and all the bad guys, this will disrupt the whole microbiome homeostatic space. Then together with your poor diet, your lifestyle and environmental toxins, the whole body now will be in a mess. Next category, we have acetaldehydes. Acetaldehydes is a toxin and potential carcinogenic compound. It can be formed in two ways, either through the consumption of alcohol or by Candida yeast through fermentations. Acetaldehydes inhibits methionine synthase enzyme in the methylation cycle, similar to heavy metals as mentioned in part 1 of the video, and also DAO enzyme, diamine oxidase, which is in the histamine pathway. So when someone drinks alcohol, it needs to be metabolized in the liver through a two-step process, whereby the ADH enzyme first oxidizes ethanol into the toxic acetaldehydes. Then it gets oxidized again immediately by another enzyme, ALDH, into a harmless acetic acid. And these two reactions require cofactors like zinc and B3. Secondly, Candida yeast will convert sugar into alcohol and produce acetaldehydes as a byproduct in the fermentation process. This also explains why someone who consumes a high-carb sugary diet tends to have a higher level of Candida yeast, which leads to an yeast overgrowth because the host is constantly feeding the yeast with sugar. So if we shift over to this strategy pathway, we can see that acetaldehydes will slow down methionine synthase here. And this junction is a very huge methylation regulator that affects downstream process, which includes your semi-productions. This will influence more than 200 over enzymatic functions. It also helps to remethylate homocysteines with the use of vitamin B12. It also causes meta-trapping when this junction is being blocked, because your metafolate can't go through these junctions to convert into tetrahydrofolate. So when you have reduced tetrahydrofolate, you start to affect your DNA and RNA synthesis, your neurotransmitters and energy productions via this purine synthesis shown here and here. And if we move forward, your MAT enzymes can also be impacted by LPS with increased markers of your TNF alpha and interleukin 6. Then productions of SAMe can also be reduced if we put these cofactors deficiency such as your magnesium, your zinc over here, and ATP. So I just flashed some of the symptoms here on the screen as you can see over here. Does these symptoms look familiar to you? They are highly associated with high levels of Candida. And these symptoms are basically all interlinked. So you have yeast in the center over here. Usually when you have yeast Candida, you actually send feedbacks to your brain, to your body to have more sugar because they are hunger for sugar and they need sugar to proliferate. When you eat a very high sugar intake, then your yeast will start to have these proliferations and start to have overgrowth. Then they will actually convert more ethanol and they will have more acetaldehydes in the process because it's a natural byproduct through the fermentations. Then when you have more acetaldehydes, you actually inhibit these two enzymes, these two primary enzymes. The methionine synthase will help to lower your SAMe productions. When you have low SAMe, you actually affect your phosphatidylcholine productions. You also affect your creatine productions. Then the downstreams more than 200 over enzymatic reactions will be slowed down. Then SAMe also will affect your HNMT enzyme in the histamine pathway. HNMT deals with intercellular histamine, which is inside the cell. And if you shift over to the left over here, you will see your diamine oxidase enzyme. Diamine oxidase enzyme deals with histamines outside of the cells. Then when you have all these inhibitors that slow down this enzyme, you cause histamine to build up. Then when histamine build up, you tend to show up more symptoms, your histamine such as your bloating. Then when your yeast starts to overgrow more and more, you get more yeast infections and even fungus growth. Like I mentioned just now, when you reduce the activity of your methionine synthase, you actually cause metal trapping. Then metal trapping will cause reduced tetrahydrofolate. Then you proceed into lesser substrates for your purine synthesis, which will affect your BH4, your biopterin pathway. There will be lesser nitric oxide productions, which can cause your high blood pressure. Then you also have reduced productions of your neurotransmitters, which will then cause your brain fog. So if you shift back on the top over here, whereby you consume a very high sugar intake, you will constantly have these insulin spikes. When your blood sugar is low again, then you will send signals for your body to consume more sugar. So you tend to eat more meals. Then these insulin spikes over time will cause insulin resistance. Then it may progress slowly into metabolic dysfunctions. When you have a lot of these dysfunctions inside our body, it creates a lot of inflammations. When you have insulin resistance, one of the symptoms or one of the signs is also weight gain. So you can see that all these symptoms, all these signs and symptoms is all related. It's all interlinked and interplay between your different systems. So a quick summary on this histamine pathway. Acetaldehydes can slow down DAO and ALDH family enzymes. Reduced activity of these two enzymes can definitely cause histamine to metabolize ineffectively, and it can start to accumulate, which can lead to histamine intolerance, also known as the histamine bucket overflowing. Then this can trigger various symptoms like hives, flushing, and headaches, because acetaldehydes also increase the release of histamine. There's also histamine producing bacteria in your gut. People are often told probiotics help your gut, but they aren't warned that some probiotic strains can actually feed the bacteria and produce more histamine. Not only does histamine producing bacteria, there's also species that produce sulfites, hydrogen and methane gases. Yes, we need both the good and the bad bacteria, but the ratio must be correct. When it's off, either feeding the wrong bug with the wrong food or prolonged antibiotic use, it can actually raise the bad bugs and kill the good guys. Abnormal ratio can lead to various health issues and may cascade into SIBO, small intestine bacterial overgrowth, irritable bowel disease, irritable bowel syndrome, even acid reflux, and many more. Even some of the good bacteria like your Akkermansia, Mucinifila, it can actually thrive on your mucin. So it's good when they are high, but you do not want them to be very high because when there's an overgrowth, it can actually thin down your mucosal lining. That's when you find a lot of these bacteria in your stool test. Furthermore, if you're someone with reduced ability to repair your gut lining, it can progress into increased intestinal permeability, also known as leaky gut. Then you will slowly progress into further stage, which will cause other gut-related issues and autoimmune disease. In terms of lab testings, I would say GI map stool test and organic acid urine test will be my preferred choice. If you're looking for more complete microbiome bacteria, including pathogens, the good and bad bugs, parasites and candida, the GI map will be the test to go. But if you want a general intestinal microbial insects, which can give you clue to mold and candida, plus all these metabolites that our body produces in various pathway and biochemical reactions, such as nutritional information and detoxification function, then the organic acid test will be able to give you a better overview. Both the GI-MET and organic acid test can detect candida, but candida can sometimes be harder to catch in stool testings. In organic acid test, we can check for yeast overgrowth when you see urine, arabinose, and tartaric acid is elevated. And over here, oxalic acids can also be high when there's signs of dysbiosis from aspergillus and candida. As always, you need someone who can help you to analyze these results functionally. Anyone can order this test nowadays, but if he or she is just treating the paper by giving you a pill for a year, it's not helping you in the long run. You have to put everything together: your lab test, your lifestyle behavior, your past medical history, your nutrition, your environment. All these factors is what make you different from everyone else. For bacterial or pathogens eradications, I like to use a more comprehensive protocol. So instead of using the normal 3R's approach, as mentioned in my past videos, I like to introduce you the 5R treatment protocol. When you do your GI map stool test, and the result comes back that you have positive all these parasites and pathogens, we do not know how long that these bugs has been living inside your body. If the pathogen is very serious or is very severe, very toxic, first you have to look for your primary care provider and they will give you these prescriptions, antibiotics to remove them. Or you can go for a more holistic approach whereby you go through a course between 30 to 90 days of antimicrobial therapy, antifungal or anti-parasites. Then at the same time, it's also best to remove all these offending foods such as your gluten and dairy. But I will also include soy and corn, and definitely these vegetable seed oils, because they can actually act as antagonists and reduce the potency of all this removal therapy you are introducing. Then the next step will be replace. Most of the time when someone have bacterial overgrowth, they will have some digestive issues, which can lead to malabsorption and malnutrition. So it may be necessary to support your digestions by supplementing some digestive enzymes, such as your betaine hydrochloride. But first, you have to rule out whether you have H. pylori bacteria. You also can use apple cider vinegar, ox bile, pancreatic enzymes such as your amylase, lipase, and protease. Then the third one will be re-inoculate by helping those healthy beneficial bacteria to regain colonizations by supplementing the right probiotics along with the use of prebiotics to help them to establish more proper microbial balance. Then we have the fourth R, which is repair. Repair here means restoring the gut health, rebuild the mucosal lining integrity, and it also means supporting the body with the essential cofactors or raw materials so that they can actually perform all these tasks. Then once repair is completed, there will be less inflammations. Then now your body can start focus on building other stuff. And finally, the last R will be rebalance. You have to address your whole body health and lifestyle factors, which includes your diet, rest, exercise, stress reductions. And you have to review your environment. When everything is done correctly, you can prevent any future GI dysfunction. Okay, we have come to the end of this video. Remember, without looking at epigenetics, the environment you are in, the food you eat, the air you breathe, and the water you drink on a daily basis, just pure genetics alone, is like aiming a wide area with a shotgun, trying to hit something, but at the same time, you damage other areas. Do you see where it goes? Thanks for watching. If you have not watched the video on methylation cycle, do click here.